welcome to an algebra video tutorial. We're working our way through direct variation, understanding what is going on in this pattern of direct variation as one variable x always affects some other variable y, and trying to show the relationship between what's changing. In particular, I want to go over graphs and how we take our direct variation equation, how we can represent the change, what's happening between my two variables on a graph. So here I've got y is equal to our constant 2.5 times x. And we're going to graph this relationship on a coordinate plane here. I've got two number lines. So I've got a number line representing my x values and a number line representing my y values. And I plot the points that show the relationship on the graph. So let's talk about what that means here. Let's find some specific points. Let's start with x equals 3. If I make x equals 3, what am I going to get back for y? Well, we put 3 in for x. And my y value should equal 2.5 times 3, which is 7.5. So I can write that out this way. If I'm going to plot the point, I can write it as an ordered pair, which means if x is 3, then we got back 7.5 for my y value. The first value is always x, and the second value is always y. So let's go ahead and plot that point on here. So we find 1, 2, 3 for x. I'm just marking that line, that's not my point, but I need to go up, and I need to also show 7.5 for y. My point is showing both the x and y values. So there's 3, 4, 5, 6, 7. And 7.5. All right, there's one point that lines up with the 7.5 for my y value, and it lines up with the 3 for the x value. So there we go. Let's find some more points. Let's see what we got going on here. Let's do x is -1. Let's do a negative value. So if x is -1, my y value should equal 2.5, that's constant, times -1, and we see that, well, that's -2.5. So as I write it as an ordered pair, if x is -1, my y value is -2.5. Now let's graph that. So on my number line, -1 for x is right here, but then my -2.5 for y values is down right here. So there would be my one point to plot for that point. All right, I'm going to do a few other points really quickly just so you get an idea of what's going to happen. Let's do x is 0. If x is 0, then y equals 2.5 times 0, which equals 0. And so we have the point 0, 0. That's also there, so let's plot that point. It's going to be right in the middle there. And let's do x equals -2. If x equals -2, then y equals 2.5 times -2, which equals -5. So we've also got the point -2, -5 on my graph. So I'm going to go over -2 down 2, 3, 4, 5. Okay, now we've only done 4 points on here, but you can kind of start to see some pattern going on here. And you could pause this video and play around on your own and put in some other things, but you can see that the point 1, 2.5 is going to be on there. You can see that the point 2 and 5 is going to be on here. We've got 3, 7.5. If I put in 4, I'm going to get 10. And you can kind of start to see 7.5. You can see what a direct variation graph looks like. Now let me ask you this. Can I put in decimals? Could I find if x is 1.5? Can I multiply that by 2.5 to get a y value? I can. There's actually, if we're working with direct variation equations, I can put in any particular number I want for x, multiply it by 2.5, and get some value back. So I'm not limited by whole numbers, even though I did those because they're convenient for us to understand it. So because I can put in any number, what we actually do then is we draw a line to show that in the direct variation, that line represents all the possible points, not just the whole number points, but all the fraction parts that I can put in, all the decimal parts that I can put in. There are as many points as I want to get in, so we draw a line, and then we draw a little arrow this way saying it keeps going that way, and a little arrow that way saying it keeps going. And there is a graph showing this particular direct variation relationship. A couple things to point out. It's a nice straight line. So all graphs have to be a straight line. That's important. If you graph it and it's not a straight line, then it's not direct variation. The other thing is we have the point 0, 0. If your graph is a nice straight line but does not go through the point 0, 0, it is not direct variation. So direct variation has to have 0, 0, because if we put 0 in for x, I gotta get 0 back for y, and it has to be a nice straight line. So there's a good introduction, a good, hopefully you understand how we can visualize and see direct variation relationship in a graph.